All right, so today's 19.2, but let's go to the 19.1 homework first. Number 1, we have yes. Oh, sorry, 1. A is no. B is yes, common difference of 2. 1C is yes, common difference of -3. Number 2, determine if it's an arithmetic sequence. Remember that means it's linear, it goes up by the same thing or down by the same constant amount. Use the explicit formula. That's the one we like. Now, these are simplified. So take a look at yours for number 2. If you haven't simplified your equation, do that now. If you have some distributing, like your D times the n minus 1, go ahead and distribute out your D minus 1. And please, from the future, always do that. I didn't tell you that, but it's not a big deal. You have your a sub 1 plus n minus 1 times d. Then distribute that through. Make sure it simplifies to this, -4 plus 8n. Yeah.
Okay, I put 4 plus n minus 1 times 8. That's what I
4 plus n minus 1 times 8. Yeah, so distribute that 8 out is what I'm saying.
Oh, okay.
A sub n equals 4 plus n minus 1 times 8. Yep, so just distribute that out. 4 plus 8n minus 8. Same thing. So, number 2, you might not have your simplified, but go ahead and do it now. Distribute the d to the n minus 1. Oh, 2 is no, so do that to c. And try to remember again in the future to always simplify it like this. I don't care if the 8 is first or the -4n is first, as long as they're both there. Number 3, determine whether it is or is not arithmetic. Write a recursive formula. The recursive formula is the term before it plus the common difference. So it looks like this. A sub n equals a sub n minus 1, the term before it, plus your difference, 0.5. You should not be correcting anything in pencil, because then I can't tell if I walk around and look at it, if you did it right the first time, or you copied the right answer. I do want you copied the right answer, but I just want to know what you had originally. You should still be getting a 10, though. And then B, your formula. Remember, this is recursive, the one we don't like. We don't like it because we have to know the term before it, and we add the difference to it. And C is no. 4, find the indicated term. So 74, 90, -23. We skipped 5, is that right? All right, any questions on 1 through 4? Maybe you got them wrong, but I think we got them fixed now. 6 is D. Oh, no, 5 was D. That's what we skipped. 6 is 900. 7 I really like. 7 you really had to think. So a sub 1 is 2. A sub 2 is 8. A sub 3 is 4. We can go over those, but I really want you to brainstorm on your own. We skipped 8, I think. 9. Did it go 9 and 10? That we did? 9. N is 11, and then they have an explanation. And 10, 2/3. 5/6. 1, 7/6. Do we want to go over? Which ones do we want to go over? 7. Any others?
10.
Okay. So number 7. Remember, it's linear, but the process I'm going to take you through is going to help us when we get to geometric sequences. So what I like to do is I like to write it like this, sort of like a table. 4, 20. My 4th term is 20, and my 12th term is 68. So then I take a look at what's happening. From 20 to 68, I went up 48. I added 48. And I did that over 8 jumps. There's 8 numbers between 4 and 12. So if I traveled 48 units in 8 jumps, I would just divide how much each one is, and that would be my difference. So 48 is what I went up, divided by 8 is 6. So my difference is 6. That's not my answer, that's my difference. I'm going to use that to go backwards. I need to know the first term. So the first term, I know that I'm going to have to go backwards. So I'm going to have to subtract 6. How many times to get from here to here? 3 times. So from 20, I'm going to subtract 6 3 times, which puts me at 2. Is that the answer? Oh. Is that what I read? So by making a table that helps me figure out how far I went and how many consecutive numbers I missed. So I missed 8 numbers between 4 and 12. So 48 divided by 8 gives me my difference. Then I work backwards. I have to go back 3 times. And each time I need to, since I'm going backwards, subtract 6. So I start at 20, subtract 6 3 times, which puts me at 2. From there, then you can find your second and your third term. Try to do it that way instead of manually going backwards, minus 6, minus 6, minus 6. In case this number was much bigger, you wouldn't be able to do that every time. Number 10. Find the first 4 terms of the sequence. Okay, so my first term is 2/3. This is an equation. It's the term before it plus this must be the difference. So I need to add a 1/6. So 2/3 plus 1/6 would give me my next term. I'm going to put that into common denominator. So that's going to be, if I turn that into 6, that'd be 4/6 and 1/6, which is 5/6. And my next term, I have to add a 6th again. So if I add a 6th again, I'm at 6/6 or 1. And the fourth term is going to be 6/6 plus 1 more 6. Anything else there? All righty. You can open your book to 19.2. Okay. 10, 8. Caitlin, Adrian, Ajaya, Charlie, Becky, Ben, Leroy, Lily, Randy, Shelby, Braden, Jaden, Tyler, Alec. All right, so yesterday was arithmetic sequences. The sequence is just a list of consecutive numbers. Today is series. So what is the series? I believe it's the first sentence in the notes. Page 299. Here we go. A series. First sentence. A series is the sum of the terms in a sequence. So not just the sequence one term at a time, it's the sum of them. The sum of the first n terms of a series is the nth partial sum of the series denoted by S sub n. Yesterday we did A sub n or A sub 5, meaning the 5th term. Today we're going to have S sub 5, which means the sum of the first 5 terms together. A sub 5, the 5th term. S sub 5, the sum of the first 5 terms. The reason it's called a partial sum is because I only want the first part. I only want 5 of them. And if it's arithmetic, it's going to go on forever. And so I can't sum them all up, but I can sum up the first 5. Consider the arithmetic sequence, 4, 6, 8, 10, 12. Find S sub 4. That means I need to add the first 4 terms. I think we can do it in our head. Need to add the first 4 terms. So 4 and 6 is 10. Got another 10, it's 20, so 28. S sub 5 is the sum of the first 5 terms. Well, we already know the first 4, so we just have to add 12 to that. So 40. And then find S sub 8. $88. That's not something you'd have to show work on. D is interesting. It says, how does A sub 1 plus A sub 8 compare? So here's A, not S. The first term added to the 8th term. Here's the first term. If I add it to the 8th term, 4 and 18, it's 22. How about the 2nd and the 7th term? Add those up. That's 22. You go and add the 3rd term with the 6th term. This pattern is going to help us create an equation. Let's skip over E and look at number 2. Number 2. Consider the arithmetic sequence. 1, 2, 3, 4, ... What's my common difference here? 1. We know the ... means there's a bunch of numbers in there. They're just not listing them out. So it goes all the way through 100. If I said, what's the 12th term? Well, in this case, the 12th term is 12. If I said, what's S sub 12? We'd have to do a lot of adding. If I said, what's S sub 100? I would have to add 1 plus 2 plus 3 plus 4. That would take a really long time. So look at the patterns we're going to observe here. And you're going to be able to find S sub 100 very quickly. Here we go. How many terms are in this series? What's the answer? How many terms are there in this series? Charlie? 100. If all of the terms in this series are paired as shown below, kind of like we paired the last one, how many pairs will there be? So I'm going to pair the first one with the last one, the second one with the second to last. If there were 100 numbers and I'm pairing them all up, Caitlin, how many pairs will I have? 50 pairs. 50 pairs. What is the sum of each pair? So I'm going to pair 1 and 100. That makes 101. I'm going to pair 2 and 99. That makes 101. I'm going to pair 3 with 98. Does that make 101? Will this continue? Yeah. So what is the sum of each pair? 101. So I've got 50 pairs, and each pair adds to 101. So how will I find the sum of all 100 numbers? Yeah. This is happening. This 101, 101, 101 is happening 50 times. So 50 times 101. It comes out to 50. Now your sequences will not always have an even number of pairs, but it will still work out. We'll kind of talk about how that works. Your sequence doesn't have to go up by ones every time. As long as it's arithmetic, it should be fine. So we've done D, which is find the sum of the series. it's nice to write it as S sub 100, the sum of the first 100 terms. Before we turn the page, let's see if we can kind of brainstorm an equation here. Of course, this is our equation for finding this specific problem. Below this, let's write S sub n. What if I just want any generic term? How do we get the 50? Yeah, we had 100 and they were all paired up. So however many you have, you're going to pair them all up. So it's going to be half of that number. So n over 2. Where did the 101? How would we come up with that? Yeah.
A1 or
A sub 1?
A sub 1 plus A sub whatever the last number.
Yeah, what would my last number be?
And this one on or n.
N, right? If I want the first 12, I would add the first term with the 12th term. If I want S sub 30, I'd add the first term and the 30th term. Very good. So you guys just figured out your formula. You can do this with any arithmetic sequence. You can find the sum of the first, any numbers you want. N over 2 times parentheses A sub 1 plus A sub n. Flip back. Do you have a formula for this in your notes from yesterday? You do. Here's what some students choose to do in your book. Talks about this later. The formula from yesterday. Ben, can you give me the formula for finding the nth term? A sub 1
Plus n minus 1 times 2.
Okay. If you choose to remember one formula, some students take this formula for A sub n and plug it in here. Some like to do it separately. I'll find A sub n. Let's say it's 32. Then I'm going to put a 32 up here. They do it two separate formulas. But let's kind of look at what it's going to be if I put that in there. Let's put a box around that one. And I'm going to get you all a note card. The front of the note card is going to be arithmetic. The back is going to be geometric. I don't think we'll be allowed to use these on a quiz, but I can let you know. So I don't care which side's the front. Pick one of the sides. Write arithmetic at the top. So this is your note card. Arithmetic. We're going to write probably 2 and up to 4 formulas. So we're definitely going to have A sub n equals the one Ben just told us from yesterday. A sub 1 plus n minus 1 times d. If you want to put the recursive one, you can. We're not going to use it much. So I'm going to write it, but not really one we use. So another way to find A sub n is to find the term before it, A sub n minus 1, and add the difference. Maybe you want to put a smiley face, or sorry, a frowny face by that one. Not super helpful. That's for finding any term, the 5th term, the 8th term, the 100th term. Let's also add our new formula for today, which is S sub n, the sum of the first however many terms. That's n over 2, parentheses, first term, A sub 1, plus last term, A sub n. I'm going to give you another optional one to put down here if you want. And so what we're going to do right now is we're going to take this formula for a sub n, and we're going to put it in here because that says a sub n. It's going to make this formula a little longer, but it will be one formula instead of two. You might need to do it off to the side. So we have S sub n equals, copy the beginning, n over 2. Copy the a sub 1. And then substitute, instead of a sub n, substitute this formula. That can be a little more simplified. Since I have two a sub 1s, I might write 2 a sub 1s plus n minus 1 times d. Your choice. I don't like that one because I have the other two already memorized, so I don't want to memorize the third. But if you like this one, you could put that on your note card also, or instead of. Alrighty, let's go back to the one we did earlier today. We did this by hand. Let's look at, for instance, S sub 5. The very first one. Braden, what was our answer? 40?
Yeah.
Okay. Let's do it using the formula, even though we could do it by hand. So we're going to do S sub 5. Formula says n over 2. So 5 over 2. We need to add our first term and our last term. Remember, we're only doing 5. So my last term is no longer 18. I'm doing the sum of the first 5. My fifth term is my last term. Comes out to be the same. So it is okay if you are adding up an odd number of things, they'll still work. You're still pairing them up, but then you'll get a half a pair, which is going to be just fine. Alrighty, let's do some practice. Go ahead and go to the bottom of 301. There are 3 questions. Let's do one at a time. So 301, first question. Everybody try it on your own, and then we'll reconvene. They start off a little more basic. S sub 8. We don't actually want to write out 8 terms and add them up. We want to do the formula, which allows us to do it much quicker no matter how many we have. 8 over 2, first term plus last term, or first term plus 8th term. All right, go ahead and try B. Have to use a formula from yesterday. Let's go over it. I want S sub 10, the sum of the first 10 terms. So I always do how many terms I want divided by 2, 10 over 2. Then I want my first term and my last term, in this case, my 10th term. I don't know my 10th term. I don't want to manually calculate that. So I do my formula for finding any term I want. A sub n formula gives me any term I want. I want the 10th term. So I follow the formula, the first term plus n minus 1 times d. I get 66. So 66 will go right in here, and that will give me my final answer of 390. Any questions on that one? Am I going too fast? Okay. Get to that third one then. So I've done n over 2, 25 over 2. My first term is 30. My last term is the 25th term, which I don't know. So I'm calculating my 25th term by doing the first term plus n minus 1 times d. My difference, I'm going down by 10, subtracting 10 every time. That negative 210 goes in here. You just put add a negative or just minus. Who likes doing it this way with two separate formulas? Who likes one bigger formula? None? All right, I think we're ready for our homework. Oopsies.